Hey guys, in this video we'll look at logarithmic functions. So say for example you have a function that looks like that. Well, we can also write this as log a y equals x. So this here is our logarithmic function, and any exponential function can be written in this way. The main thing to note that the power in our exponential function becomes the answer in a logarithmic function. For example, if we had 2 raised to 3 equals 8, as a log we can write that as log. Our base here becomes 2, and our answer in our exponential form goes there, and the answer that we end up getting is the power. Let's look at another example. So if we had 10 raised to 4 equals 10,000, as a log we can write that as log base 10,000 equals, our power here is 4, equals 4. So you may get questions where we've got 2 raised to x equals 16. And we may want to write this in a way or rearrange it in a way where x becomes the subject. So that's where we would write that as a log again. So log, our base is 2 of 16 equals x. Now say for example you had a question where you wanted to solve for x, and the question was log 3 of 27 equals x. So how would we solve this? So the first thing to note is we can write this as 3 to the power of x equals 27. And we know that 27 is really 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So now we can write this 27 as 3 raised to 3. Now because our bases are the same, so this is 3 raised to x, and that equals 3 raised to 3, which means our powers equal each other. So we can say that x equals 3. Let's look at another question. So say we have log 2 of 16 equals x. So again, we can rewrite this as 2. Remember, x, the answer, is really our power, to the x equals 16. Now again, let's rewrite 16 in terms of 2 to the power of something. So we know that 16 is really 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 is really 2 to the power of 4. So we can write this as 2 to the power of x equals, now 16 can be written as 2 to the power of 4. Now because both our bases are 2, we can let the powers equal each other. And we can say that x equals 4. Let's look at one more example. Say we are told that log 5 of 125 equals x plus 1. So how would we solve this? So again, let's follow our rule that this can be written as 5, because that's our base here, to the power of, so this is our power, x plus 1 equals this number over here, 125. So now again, the next step, let's rewrite 125 in terms of 5 to the power of something. So we know that 125 is the same as 5 times 5 times 5, because 5 times 5 is 25, 25 times 5 is 125, which is the same as 5 to the power of 3. So now we can rewrite it as 5 to the power of x plus 1 equals 5 to the power of 3. Now because our bases are the same, 5 and 5, we can let the powers equal each other. So we could say x plus 1 equals 3. And now all we have to do is solve for x. So we can minus 1 on both sides, and we're going to get x equals 2. Now, just to recap, in this only works for a being a positive number and when a doesn't equal 1. And because of that, because a is positive, a positive number to the power of any number will always give you another positive number. So that means y is always positive. And because of that, you can only do logs of a positive number. If your y is negative, this will give you an error when you try and work it out. Alright, let's do one more example. Say log 381 equals 3x minus 11. Alright, so again, let's rewrite this in an exponential form. So this is the same as saying 3 to the power of 3x minus 11 equals 81. Okay, so now let's rewrite 81 in terms of 3 to the power of something. So 81 is the same as 3 times 3. Well, 3 times 3 is 9 times 3 is 27 times 3 gives us 81. So 81 is 3 to the power of 4. So you can write this as 3 to the power of 4 equals 3 to the power of 3x minus 11. Now, because our bases are the same, we can make the powers equal each other. So 3x minus 11 equals 4. Now, if we add 11 on both sides, because now we just have to solve for x, we're going to have 3x equals 15. And then if we divide by 3 on both sides, we'll have x equals 5. So, just to recap, whenever you have a raised to x equaling y, we can rewrite that as log of a y equals x. So when you write it in this form, the power becomes our answer. And this only holds true when a is greater than 0 and a doesn't equal 1. And because a is greater than 0, a to the power of any x value will always return a positive y value. So our y should also always be greater than 0. In other words, if your y value is negative, you cannot find the log of that.